and let us find out. So the first example is we will find out the S parameter of an impedance Z which is in series. A series impedance Z, let us find out its S parameter, which means we have a transmission line of characteristics impedance Z0. In the transmission line, over a section we have cut out a section of transmission line, there we have put a impedance Z. So you can see the figure. Now if you look at the figure, we have the impedance Z. Now impedance Z has two ports, one is towards the right, one is towards the left. These two ports are connected to two transmission lines. So we have a transmission line on the left side, we have a transmission line on the right side. So what we will do is, for each transmission line we will consider a separate coordinate system. So for the right one we have a coordinate system, for the left one we have a coordinate system. So we have two different coordinate systems. For the right hand, the coordinate system is giving you Z2, which is moving in the left direction. The positive direction is from right to left. For the left hand side, the positive direction is from from left to right. So we have two different coordinate systems. We are using that we will use. Why? The reason is it will make the analysis simplified. So when you have such type of configuration where you have more two nodes, and to the two nodes we are connecting two transmission lines for giving you the ports, then you can use always two coordinate systems or three coordinate systems. If it is more than two, even if it is two, you can use three coordinate systems. So we'll start with the S11 parameter. So calculation of S11. For S11 we have to look from the port 1. So that is, the port 1 is from the left hand side. So we have A1 and B1 as the wave parameters coming towards Z and going out from the Z respectively. Z0 is the characteristics impedance of the transmission line, and the point where the transmission line is connected to Z0, that on that port, there the voltage across those 2 points is V1. See, upper one is plus, lower is V minus, so that is V1. Now at that point, from that point, if we look into the that point is Z1, so that is other thing. Z1 is the location. So the coordinate value is Z1 for that. And if you are looking towards the load, towards the impedance Z, then the input impedance is Zin from that point. That is the port where transmission line is connected to the impedance Z. At that port, if you look from the transmission line side towards the impedance, then the input impedance at that point is Zin. So we are going to calculate S11. Okay. Now S11 by definition is B1 by A1 when A2 is equal to 0 and A2 is not equal to A1. A2 is equal to 0, B1 by A1. Now 0 represents the reference point, that you can write also as we have seen for non-normalized case, V1 minus by V1 plus. So B1 by A1 or V1 minus by V1 plus. Now that will be equal to, what is V1 minus and V1 minus by V1 plus, and V1 minus by V1 plus is the reflection coefficient at the point 1, at the port 1. So reflection coefficient, as you know, for reflection coefficient, the expression for reflection coefficient gamma is Zin minus Z0 by Zin plus Z0. So V1 minus by V1 plus, that will be equal to Z in minus Z0 by Z in plus Z0 at A2. Now what will be Z in? And the input impedance, if you look into the impedance Z, then at that point, exactly at that point, the characteristics impedance is Z0. Then to that Z0 there is a series impedance Z. So Z in will be Z0 plus Z. So for Z in, let us put Z plus Z0. If you put Z plus Z0, in the numerator you will get Z plus Z0 minus Z0. In the denominator you will get Z plus Z0 plus Z0. So in the numerator Z0 will cancel out, leaving out Z. In the denominator Z0 will be added up, leaving out Z plus 2Z0. So S11 is equal to Z by Z plus 2Z0, where Z is the impedance, Z0 is the characteristics impedance of the connecting transmission line. Now by symmetry, if you look from the left side, from the right side, we will find the same thing. Therefore, by symmetry, S22 is equal to S11, that will be Z by Z plus 2Z0. So now we have found out S11 and S22 for the transmission line. Next is we have to find out S21 for this transmission line, which has the impedance Z at over a section. Okay. Now S21 by definition is B2 by A1 at the reference point. So when small z is equal to 0. For A2 is equal to 0. That you can write as V2 minus by V1 plus at reference point when A2 is equal to 0. That is how you can write V21. Now what is V2? B2 is equal to V2 minus Z2. Why? Look at the figure. If you look at the figure, V2 is the voltage across the point where this impedance is connected to the second transmission line on the right hand side. Now that voltage is the voltage on the transmission line. Therefore, V2 Z2 at that point, the voltage at Z2 is equal to V2 minus Z2. So that will be equal to V2 minus 0, that is V2 Z2. Z2, when we are considering, it is away from the reference point. So if at the reference point voltage is V2 minus 0, that is the reference voltage, V2 minus 0 is the reference voltage, that into exponential jkz2 Z2. What is jkz2? Why plus kz2? Because it is moving in the left direction. From the right to left, it is coming from right to left. That is why it is exponential jkz2 into z2. Then you know the voltage divider principle. Let us use the voltage divider principle. V2 minus 0 is equal to V2 0, and this we have seen already. I have explained this. V2 minus 0 is equal to V2 0 when you are putting Z0, Z2 is equal to 0, or when you are considering the reference point. So at the reference point, Z is equal to 0, small z is equal to 0. So Z2 is equal to 0. We are considering the second transmission line. So Z2 is equal to 0. So V2 minus 0 is equal to V2 0 when you have put Z2 is equal to 0 in the first equation. In the second equation, when you put V2 is equal to 0, you get this. Now what will be that? That will be equal to the voltage given at port 1 divided across Z. So that will be V0, V10, Z0 by Z plus Z0. You know, if you have two resistances R1 and R2, and you are applying a voltage V across these two resistances in series R1 and R2, apply a voltage V across these two resistances, then you take and find out the voltage across R2, that will be R2 by R1 plus R2 into voltage V. So use that principle, voltage divider principle. So V2 you are getting from V1. So therefore V20 is equal to V1, that is the applied voltage, and that is, and you are getting that across Z0, since it is the Z0 point, so you are getting at across Z0, so that is V1 into Z0 by Z plus Z0. Okay. Input voltage V1 is equal to, slow. Now input voltage V1, that is equal to V1 into 1 plus S11. How do you get this? This is also simple. V10 is equal to V10 plus V10 is equal to V1 plus V1 minus. Now if I take V1 plus common, then V1 plus whole into 1 plus V1 minus by V1 plus. V1 minus by V1 plus is S11, reflection coefficient gamma. Therefore input voltage is V1, that is V1 plus whole into 1 plus S11. So that we know. Then from the third equation, this equation for V2 minus, which is the third equation, from that equation we will see that V2 minus 0 is equal to, for V1 we can put V1 plus into 1 plus S11, then Z0 by Z plus Z0. So on that equation only, for V1 0 you put V1 plus into 1 plus S11. So from the third equation we have got this. Now that will give us S21. Why? S21 is equal to V2 minus by V1 plus. Now you have got V2 minus is equal to V1 plus into 1 plus S11 into Z0 by Z0 plus Z. Now if I take V1 plus to the left hand side, so I will divide it in the left hand side, both the sides. If I divide by V1 plus, then I will get S21, which is V2 minus by V1 plus, that will be 1 plus S11 into Z0 by Z plus Z0. S11 we know. So if you put those values for S11, we will get what is S21. So S21 is equal to 1 plus S11 into Z0 by Z plus Z0, that is equal to 1 plus S11 is Z by Z plus 2Z0, that into Z0 by Z plus Z0. Now if you do the algebra, then the first part will be 2Z0 into 2Z is the numerator, denominator is Z plus 2Z0, that into Z0 by Z plus Z0. Now Z plus Z0 is in the numerator, is in the denominator, they will cancel out, leaving out 2 in the numerator. So this will be 2 into Z plus Z0 by Z plus 2Z0 whole into Z0 by Z plus Z0. So that will be S21. Now by symmetry, S12 is equal to S21 is equal to 2Z0 by Z plus 2Z0. So this is for this transmission line. Now let us see another example. Find the S parameter for a length L of a transmission line. So there we saw an impedance Z inserted between with the transmission line in series. Now here we will see, find out the S parameter of a transmission line of section of length L, transmission line section of length L. So that part is shown in black. If you look at the figure, this part is shown in black. The transmission line of section length L, its characteristics impedance is ZS, beta S is the propagation constant or phase constant or wave constant, and this is connected to two transmission lines of characteristics impedances Z0 on its two ends. So then here you can see that there are three transmission lines. Since there are three transmission lines, we will use three coordinate systems. One coordinate system each for each transmission line. So for the left one, we will have the coordinate system which will give us Z1. For the middle one, we will have a coordinate system which will give us small z. For the right one, which is the transmission line 2, we will have a coordinate system which will give us Z2. So that is shown in the figure. Now we will calculate S11. Now you know on gamma L, the reflection coefficient is equal to Z0 minus Z0s by Z0 plus Z0s. Now why it is Z0 minus Z0s by Z0 plus Z0s? Because this transmission line, for this transmission line, the load impedance is input impedance is Z0, and characteristics impedance for this transmission line section is Z0s. Since for this transmission line section, characteristics impedance is Z0s, and to that section we are looking at the input impedance. Input impedance is Z0 because input impedance is the impedance of the connected transmission lines which have characteristics impedance Z0. They are semi-infinite in extension. Therefore, their characteristics impedance is the input impedance to the transmission line of section L. So Z0 gamma L is equal to Z0 minus Z0s by Z0 plus Z0s. Now S11 is equal to B1 by A1 at A is equal to 0. When A is equal to 0, S11 is equal to B1 by A1. That you can write as Zin minus Z0 by Zin plus Z0. Zin is found out at A2 is equal to 0 because we are finding out S11. S11 is under the condition A2 is equal to 0. Now that is equal to S22. This is by symmetry. S11 is equal to S22. It is by symmetry. Now let us find out what is Zin. Zin at A2 is equal to 0. That you can find out using the formula for input impedance of transmission line. Zin is equal to ZOS. OS is the characteristics impedance into Z0 plus JZ0S tan beta SL divided by Z0S plus JZ0 tan beta SL. This is the transmission line formula. This we are using. That also you can write as Z0S into, if you are not writing in this form, in the form of gamma L, if you are using it in the form of gamma L or the reflection coefficient, then it will be Z0S whole into in the numerator 1 plus gamma L exponential minus J2 beta SL, in the denominator 1 minus gamma L into exponential minus J2 beta SL. So this is what is Zin. Now S11 is equal to S22 is equal to, put the value of Zin. So in the numerator Zin minus Z0, for Zin you can put Z0S whole into Z0 plus J Z0S tan beta SL divided by Z0S plus J Z0 tan beta SL whole divided by, again Z0S into numerator will be Z0 plus J Z0S tan beta SL by Z0S plus J Z0 tan beta SL, because that is the Zin when A2 is equal to 0, then plus Z0. Now if Z0S is equal to Z0 in this equation, suppose Z0S is equal to Z0. If Z0S is equal to Z0, then Zin is equal to Z0. That implies that S11 is equal to S22 is equal to 0. If Z0S is equal to Z0, then the first part will be equal to 0 Z0. So that will make it Zin is equal to Z0. So that will make S11 and is equal to S22 is equal to Z0 minus Z0 by Z0 plus Z0. Z0 minus Z0 is equal to 0. So that will make it 0. Otherwise the expression is this. Now we have to calculate S21. To calculate S21, the expression for S21 is equal to B2 by A1 when A2 is equal to 0. So that will be V2 minus by root over of Z0, that is definition of V2, divided by definition of A1 is B1 plus by root over of Z0, that at A2 is equal to 0. Now since root over of Z0 we can cancel out, so that will give us V2 by V2 minus by V1 plus for V2 minus is equal to 0. That is V2 minus at 0. So in the division V2 minus at 0, V2 plus at 0. Now total voltage at port 1, we have to calculate this V2 minus and V1 plus. Now total voltage at port 1, V1 is equal to V1 plus into 1 plus S11. This I have already explained, so I am not going to explain this one anymore. For the denominator of S21, on the equation V1 plus is equal to V1 0 by 1 plus S11, that comes from the above equation. V1 0 back, V1 0 is equal to V1 plus into 1 plus S11. From that you can get V1 plus is equal to V1 0 by 1 plus S11. So for the denominator we have got the expression. Then we have to get the expression for the numerator. Okay. V2 minus is equal to V2 0, that is Vs, which is equal to Vs plus into 1 plus gamma L. It is again the same principle, so I am not going to explain it once more, because Vs is equal to Vs plus plus Vs minus. Take Vs common, then that will give you Vs into 1 plus Vs minus by Vs plus, which is gamma L. So V2 is equal to Vs plus into 1 plus gamma L. Now you have to get what is Vs plus in terms of V1 0. So that is what we have to do. So Vs is equal to Vs plus at the reference, Vs at any point Z is equal to Vs plus at reference is 0, into exponential minus j beta s z whole into 1 plus gamma L exponential plus j2 beta s z. This how we have discussed when we discussed about transmission lines, how you will get this. This we have already discussed, so I am not going to discuss it once more. But if you want, you can just multiply that. If you multiply, the first part is Vs plus 0 exponential minus j beta sz, and the second part is Vs plus into gamma L, that gives you Vs minus 0 into exponential j beta sz. So from that we have taken the first part common. Now V1 0, from this you will find, this implies that V1 0 is equal to Vs of at the length z is equal to L. So Vs length is equal z is equal to L, and reference is taken at the right hand side. So at the left hand side it will be minus L. So Vs minus L, V10 is at the for the transmission line 1. Then you have the midsection is Vs. So Vs minus L, it is at the left hand side of the Vs, that is why V1 and Vs are same. Vs minus L is equal to V10. V10 is the reference point for the first transmission line, and then you have the transmission line section of length L. So the left hand side of the transmission line of the section is at a distance minus L for the reference for the second transmission line. Reference for the first transmission line is at Z0. So these two are same. V10 is equal to Vs minus L. Now that you can write as Vs plus Vs minus L, that you can easily find out. For small z you put capital L. So Vs plus 0 exponential j beta s L whole into 1 plus gamma L exponential minus j2 beta s L. From that you can say Vs plus 0 is equal to V10 by exponential and j beta s L whole into, in the numerator, 1 plus gamma in the denominator, 1 plus gamma L exponential minus j2 beta s L. Now you have got Vs plus 0. So since we have got Vs plus 0, we have got V2 minus 0 also, because V2 minus 0 is in terms of Vs plus 0, that into 1 plus gamma L. So we have got V2 minus 0. Okay. So from that we find out expression for V2 minus 0, which will be now V1 0 divided by exponential j beta sl whole into in the denominator whole into 1 plus gamma L exponential minus j2 beta sl, and this whole factor into 1 plus gamma L, that is V2 minus 0. Then S21 is equal to V2 minus by V1 plus. So V2 minus 0 by V1 plus 0, that you can easily find out. That will be equal to V2 minus 0 expression we have got, V1 plus 0 expression we have got. Divide them, that will give us 1 plus S11 into 1 plus gamma L into exponential minus j beta SL whole divided by, in the denominator we will have 1 plus gamma L exponential minus j2 beta SL. Now S21, we have found out what is the expression for S21. S21 is equal to 1 plus S11 whole into 1 plus gamma L whole into exponential minus j beta SL, all these three in the numerator divided by 1 plus gamma L exponential minus j2 beta SL. Now that is by symmetry of the S matrix, that will be equal to S12. So we have found out what is S11, we have found out what is S22, we have found out what is S21, we have found out what is S12. Now we will consider some special cases of this example. Now the special cases, we have this transmission line of length L. Now the first special case is ZOS is equal to Z0. If ZOS is equal to Z0, then S11 is equal to S22 is equal to 0, gamma L is equal to 0. Use this, then S21 is equal to S12 is equal to exponential minus j beta SL. So if this transmission line has the same characteristics impedance as the connecting transmission lines, then S11 and S22 are 0, S21 is equal to S12 is equal to exponential minus j beta SL. It is a two-port network, so we will have a 2 cross 2 matrix for S matrix. So S matrix will be 0, first row will be 0 exponential minus j beta SL, and second row will be exponential minus j beta SL into then 0. So that also you can write as exponential minus j beta SL into unit matrix. Okay. Then the second condition is L is equal to lambda g by 2. You can consider many more special cases. Here I am considering only L is equal to lambda g by 2. L is equal to lambda g by 2 shows that beta SL is equal to, beta S is 2 pi by lambda g. So on 2 pi by lambda g into lambda g by 2, that is equal to pi. So beta SL is equal to pi. If beta SL is equal to pi, then Z in is equal to Z0. That implies S11 is equal to S22 is equal to 0. That remains as it is. Then exponential minus j beta SL is equal to minus 1, because beta SL is equal to pi. Exponential minus j beta SL is equal to exponential minus j pi, that is equal to minus 1. And exponential minus j2 beta SL is equal to plus 1. So that implies that S21 is equal to minus 1. So we have got S11, S22, S21, S12. So S12, S21 are minus 1. So the S matrix here under this condition, S matrix will be S is equal to 0 minus 1 minus 1 0. 2 cross 2 matrix. 0 minus 1 minus 1 0. Okay. Then we will consider the third example. Third example is a stepped transmission line, which means two transmission lines. You connect two transmission lines. One is of characteristics impedance Z01. First transmission line is of characteristics impedance Z01. This extends towards minus infinity in the left hand direction. Second transmission line is of characteristics impedance Z02 that extends to right towards minus infinity. So both are semi infinity in uh, length. One is towards left, one is extends towards right. They are joining. So at that joint we have a joint. So that is the step. The joint is the step. Now, since we have the continuity, since the two transmission lines are connected, so there is a continuity. Because of continuity of voltage across the junction, we will have V2 and 0 is equal to V20 at A2, V2 minus 0 is equal to V20 at A2, that will be equal to V10 at A2. Now you can see what is V20, what is V10. V20 is the at the reference for the transmission line 2 which is on the right hand side. V10 is for the transmission line on the left hand side, and both these should be equal at the junction. So V2 is equal to V1 at the junction. One junction or 2 points, between 2 points you cannot have more than one voltage, there can be only one voltage. So at the junction V2 minus is equal to V20 is equal to V1 and 0. Now what is V10? V10 is equal to V1 plus into 1 plus S11, that we know. Then S21 is equal to V2 minus by root over of Z02 divided by V1 plus by root over of Z01. Remember this. In the numerator we have root over of Z02. In the denominator we have root over of Z01. So S21 is equal to, because on the right hand side we have the transmission line 2, on the left hand side, to a left hand side is port 1. So towards port 1 we have transmission line 1. So B is for port 2, is at the port 2 we are considering B2. B2 by A1. So B2 is V2 minus by root B2 minus by root over of Z02. Then A1 is V1 plus by root over of Z01. This is for A2 is equal to 0. So that you can write as for V2 minus, we have found out the expression V1 plus into 1 plus S11. So numerator will be V1 plus into 1 plus S11 by root over of Z02 divided by V1 plus by root over of Z01. Now V1 plus they will cancel out. Okay. So they will cancel out. They will cancel out, leaving you out 1 plus S11 by root over of Z02 into root over of Z01. Now you will get 1 plus S11. From this you will get 1 plus S11 is equal to 1 plus Z02 minus Z01 by Z02 plus Z01. Why S11 is the reflection coefficient? Since it is the reflection coefficient, it is the Zin minus Z0 by Zin plus Z0. If you are looking from this side, side 1, then Z0 is Z01 and Zin is Z02. So Z02 minus Z01 by Z02 plus Z01, that is S11. So 1 plus S11 is equal to 1 plus Z02 minus Z01 by Z02 plus Z01. That you can write as, if you do the algebra, that will give you 2 Z02 by Z02 plus Z01. So 1 plus S11 is equal to 2 Z02 by Z02 plus Z01, from which you can get S11. What is S11 that you can get? Okay, and the S11 we already know. Now S21 is equal to 1 plus S11 by root over of Z02 into root over of Z01. Root over of Z01 by root over of Z02. So that will be 1 plus S1, that will be S21 will be 1 plus S11 into root over of Z01 by Z02. So S21 is equal to S12, that will be 2 times root over of Z02 into Z01 divided by Z01 plus Z02. So these two you can find out. Okay. Then we will consider on the last example, find the input impedance looking into port 1 when ports 2 and 3 are terminated in 50 ohms. It is shown you on the 3-port network is shown below. Look at the 3-port network. We have port 1, port 2, port 3. When 2 and 3 are terminated in 50 ohms, find out what is the input impedance looking into port 1. That is condition 1. First question. Second question is find the input impedance looking into port 1 when port 2 is terminated in 75 ohm and port 3 is terminated in 50 ohm. And you will find out for this it is a not unitary S matrix. S is equal to diagonal elements are 0. Upper you will see minus j by root 2, minus j by root 2, and second row you will have minus j by root 2. Diagonal elements are 0. Off diagonal elements 2 off diagonal elements are 0. All other elements are minus j by 2 root 2. This is not a unitary matrix, so it is a lossy matrix. Since it is not a unitary matrix, it is a lossy matrix. S matrix is a lossy matrix. Now let us find out for this. Let us find out these parameters. The input impedance. S matrix is given. This is given. The network is given. S matrix is given. We have to find out the parameters, input impedance, etc. So Z in when port 2 and 3 are terminated in 50 ohm, when port 2 and 3 are terminated in 50 ohm means A2 and A3 is equal to 0. 50 ohm means it is matched condition. It is terminated in matched load. So A2 and A3 these are 0. So there is no reflection. So if you look at the figure, it shows that there is no reflection. Gamma 2 is equal to 0, gamma 3 is equal to 0, which means A2 and A3 as 0. Z in if 2 and 3 are terminated in 50 ohm, matched condition, perfect matched condition. So A2, A3 are both 0, gamma 2 is equal to 0, gamma 3 is equal to 0. Okay, now you have to find out what is gamma in. Okay. B1 is equal to, in this condition, B1 is equal to S11A1 plus S12A2 plus S13A3. A2 is equal to 0, A3 is equal to 0. Though. So the second term, third term goes out. So gamma in 1 is equal to B1 is equal to S11A1 or S11 is equal to B1 by A1, that is gamma in 1. So gamma in 1 is equal to B1 by A1, that is equal to S11. Now that will be equal to 0. If it is matched condition, then S11 will be equal to 0. That will imply that Z in 1 is equal to Z01. Gamma in 1 is equal to 0. You will imply that Z in 1 is equal to Z01. Now why that is equal to 0? Because we have seen that in the matrix, S matrix, S11 is equal to 0. So S11 0 is implies that Z in 1 is equal to Z01. Okay. Now using this we can write for the S matrix and A, B, C parameters B1, B2, B3 is equal to the S matrix into A1, A2, A3. S matrix I have told you this is given. So this is what it is, which means Z in if Z in is equal to Z01, S11 is equal to 0, reflection coefficient is equal to 0, then there is no reflection, which means perfect matching. Perfect matching means impedance is perfectly matched, which is 50 ohm. Z in is equal to 50 ohm. So that gives you Z in is equal to 50 ohm. Then let us find out from that, we will find out B2 by A1 is equal to S22 plus S22 into A2 by A1 plus S23 into S3 by A1, that is equal to S22. B2 by A1 is equal to S22 because S22 is equal to 0. S23 is equal to 0. Look at the S matrix. S22 is equal to 0 in the S matrix. S23 is equal to 0 and A3 is also 0. So if you put this, then B2 by A1 is equal to S21. So B2 by A1 is equal to S21. Okay. Now we will come to the second condition. Z in if port 2 is terminated in 75 ohm and port 3 is terminated in 50 ohm. Okay. When port 3 is terminated in 50 ohm, it is perfectly matched. Therefore, gamma 3 is equal to 0. Port 2 is terminated in 75 ohm, so then it is not perfectly matched. Then you can find out what is gamma 2. Gamma 2 is equal to Z in minus Z0 by Z in plus Z0. Z in is 75, so 75 minus 50 by 75 plus 50, so that will give you 25 by 125, which is 1 by 5. So gamma 2 is equal to 1 by 5. We have to find out what is gamma in, and gamma 3 is equal to 0. We have to find out what is gamma in. Gamma 2 is equal to A2 by B2, that is 1 by 5, that we have found out. Okay. A3 is equal to 0, that I have told you already, because port 3 is matched. A3 is equal to 0. Gamma 3 is equal to A3 by B3, that will be again 0. Okay. Then the S matrix, in the S matrix form, relation between B matrix and A matrix is B1, B2, B3 is equal to S matrix into A1, A2, A3. Now find out B2 by A1, which is equal to S21 plus S22, A2 by A1 plus S23, A3 by A1. A3 is equal to 0. S23 is equal to 0 from the S matrix. S22 is equal to 0 from the S matrix. So that is again S21. So if that is S21, then gamma in 1 is equal to B1 by A1, that is S11 plus S12 A2 by A1 plus S13 A3 by A1. Now A3 is equal to 0. From the S matrix, S11 is equal to 0. So gamma in 1 is equal to B1 by A1 is equal to S12 into A2 by A1. Now remember that A2 is equal to gamma 2 into B2. And by definition, gamma 2 by into B2 is equal to A2. So A2 is equal to gamma 2 by into B2, put that. So S12 into gamma 2 into B2 by A1, gamma in 1 is equal to S12 into gamma 2 into B2 by A1, that is S12 into gamma 2 into S2, because B2 by A1 is equal to S21. So S11 into gamma 2 into S21. Now put the values. S11 is equal to minus j by root 2. Gamma 2 is equal to 1 by 5. S21 is equal to minus j by root 2. Minus j is minus 1. So numerator is equal to minus 1. Denominator is 5 into root 2 into root 2. That is 5 into 2, which is 10. So gamma in 1 is equal to 1 by 10, minus of 1 by 10. So Z in is equal to 50 into 1 plus gamma in by 1 minus gamma in. Cat Z0 into 1 plus gamma in by 1 minus gamma in. So Z in 1 is equal to 50 into 1 plus gamma in 1 by 1 minus gamma in 2. That will be, just put the values of gamma in 1, gamma in 2. So that will give you, so 44.55. So that is about gamma in. So that completes the examples. So you can see more examples in the book. You can work out problems from the book. Pujar. So that will complete your S matrix, knowledge about S matrix. Finally, we'll come to two parts. There are two parts, two more parts. One is relation between ABCD parameters and S parameter. Let us start with this. This will assume, because you know ABCD parameter is valid only for two port network. So here we will consider a two port network. So that is point 1. Second, we will assume that both the ports have characteristics impedance Z0. Port 1 and port 2, at both the ports characteristics impedance is Z0. So that is what we assume. Now with that assumption, let us start with S matrix. S11 is equal to V1 plus by V1 minus when V2 plus is equal to 0. Okay, this is by definition. Then V1 we know is equal to V1 plus plus V1 minus. Now on V1 also we know from ABCD parameter, V1 is equal to AV2 plus BVI2. This is by definition from ABCD parameter. Okay, V1 is equal to V1 plus V1 minus, that is equal to AV2 plus BI2. So from this you can say V1 plus V1 minus is equal to, if I take V2 common on the right hand side, then A plus B into I2 by V0, V2, I2 by V2 is equal to Z0, characteristics impedance is Z0. So A plus B by Z0 into V2 minus. Okay. Then I1 is equal to 1 by Z0 into V1 plus minus V1 minus. That you can write as CV2 plus DI2, that is from on the ABCD parameter definition. I1 is equal to CV2 plus DI2, like V1 is equal to AV2 plus BI2, I1 is equal to CV2 plus DI2. So you can write this. Now on the right hand side again take V2 common. If you take V2 common, you again get C plus D into I2 by V2. I2 by V2 is again Z0. So 1 by Z0. So D by Z0. So C plus D by Z0 into V2 minus. Okay. Now you know V2 is equal to V2 plus V2 minus. This we know, and minus I2 is equal to 1 by Z0 into V2 plus minus V2 minus. This also we know. So we are going to use these vectors. Start with V1 plus V1 minus. V1 plus V1 minus is equal to A plus B by Z0 divided by C plus D by Z0 into I1. So that you can write as A plus B by Z0 by C plus D by Z0. That into, for I1 you put 1 by Z0 into V1 plus minus V1 minus. So that you can write as, if I multiply 1 by Z0 in the denominator, so multiply that, that gives you the denominator is CZ0 plus D, numerator remains as A plus B by Z0 whole into B1 plus minus B1 minus. Okay. Then S11 is V1 minus by V1 plus when V2 plus is equal to 0. That you can write as B1 minus by B1 plus, that you can write as this: A plus B by Z0 divided by C plus CZ0 plus D minus 1, and divided by A plus B by Z0 divided by CZ0 plus D plus 1. This you can find out because we have already expressions for B1 plus B1 plus B1 minus divided by B1 plus minus B1 minus. From that expression you can find out what is B1 minus by B1 plus. This will be the expression for B1 minus by your B1 plus. So now you do the algebraic manipulation, that will give you A, numerator will be S11, numerator will be A plus B by Z0 minus C by Z0 minus D, and the denominator will be A plus B by Z0 plus C Z0 plus D. Similarly, you can find out what is S12, S21 and and S22. So expressions for S11, S22, S22. So everything you can find out in the similar manner. Then we'll come to, finally we'll end with shift in reference plane. This is important, but this may not be from your examination point of view. This may not be important. Now, as we have discussed transmission line, as we have discussed transmission line, we have seen that at different points along the transmission line, at different points on the transmission line, you will have different currents and different voltages. So the power will be different at different points. So if you are taking the reference point at Z is equal to 0, and there you are finding out your S parameter, that is no problem. Now reference point at z is equal to 0 and you are finding your S parameter at z is equal to z at at some distance from the reference point, which means you are shifting the reference point from z is equal to 0 to z is equal to z. So let us shift the distance on the left hand side. Look at the figure. We have a device. It has two ports, 1 and 2. From the port 1, wherever it is at Z1. The reference point is at Z1. For port 2, reference point is at Z2. Coordinate Z2 for port 2 and for port 1 coordinate Z1. Now the reference point for port 1 is shifted towards left by an amount L1. So Z1 now becomes, instead of Z1 becoming 0, Z1 now becomes minus L1. So when Z1 becomes minus L1, whether the S parameter will remain same or the S parameter will change. Whether the S matrix will remain same or S matrix will change. Similarly, on the right hand side, Z2 is shifted by an amount by a distance of minus L2. Whether it will remain same, S matrix will remain same, elements of S matrix will remain same or they will change. Okay. And here Ij are 1 or 2. They represent the port number. So let us, when they are shifted, let us say that the elements of the S matrix have changed. Okay. If they have changed, then the changed element is S dash Ij. Original element is Sij at the reference point Z2 is equal to 0 or Z1 is equal to 0 if you take that reference point. So that is Sij. Now it has changed. We have changed the reference point. So that gives you Sij dash. How do you define that? We will define Sij dash as Bi by Aj, but now it is not Bi0 or Aj0, it will be Bi and Aj but the transformation will be shown here. So the shift will be shown here. So Zi is not 0, Zj is not 0. They represent the shifts. So Bijj, Aj, Zj. Bij, Aj, Zj. So that will imply that since we are changing from reference point, at reference point it will be B0. So Bi0 at the reference point Ai will be Aj0, Aj will be Aj0. So Aj0, then the shift, due to shift, there will be a shift by, there will be a phase change. The phase change will be of the form exponential gamma I Zi for V and minus exponential minus gamma JZJ for A. These will be the shifts in the phase. So that you can write as Bi0 by Aj0 exponential minus gamma I Zi is equal to Li. Similarly, for the denominator, it will be exponential Aj exponential plus gamma j, then Lj. K is not equal to 0, Ak is equal to 0. Now that you can write as Bi0 by Aj0, that is equal to Sij. So write Sij. Then you have got exponential minus gamma I Li. So that remains as exponential minus gamma I Li. Then in the denominator you have exponential minus gamma j Lj. Now 1 by exponential gamma j Lj is equal to exponential minus gamma j Lj. So that you can write. So Sij dash is equal to Sij into exponential minus gamma I Li into exponential minus gamma j Lj. So if the reference is changed by a distance L, so whether it is L1, L2, L3, so according to your I and J, J is the port towards port 2, suppose I is towards port 1, so accordingly you can change, find out what is the new S parameter in the shifted form. So suppose you one example I'll tell S parameter is given. So S is equal to something. Suppose S is equal to 1, 2, 3, 4. Two port network we are considering. S is equal to 1, 2, 2, 4, 3, 4. Then it is shifted by an amount L towards the left side only. Then what will be the value? That can be the, then what will be the new S parameter? That can be your question. So with that, we come to the end of S parameter and ABCD parameter. So network analysis, now we have completed network analysis. I think we have now completed 3 units, unit 1, unit 2 and unit 3. Only unit 4 is remaining. We will do that later. If you have any questions or doubts, please ask me. Otherwise, I will stop here. এটাকে বলো ক্রোম গুজা stop sharing. તમે એઠું કરો ક્લિક કરો stop sharing. So if you don't have any questions,